Today we shall discuss some typical problems on complex numbers. First, we discuss something about complex number, which is very simple. Let Z be a complex number. Let Z be a complex number, and we defined Z is equal to x plus iy. This was the definition of the complex number, where x and y are both real. X is called the real part. This is called the real part of the complex number, and y is called, this is called the imaginary part. Imaginary part. So the number that can be written in the form z equal to x plus iy, where x and y are both real, and here x is called the real part, y is called the imaginary part, and I is our root over minus 1. This is the imaginary number. And what do you mean by the modulus of the complex number? Modulus of the complex number mod z is equal to root over x square plus y square. Next we take another definition of complex numbers. Let x equal to r cos theta and y equals to r sin theta. Then you can write z equal to r into cos theta plus I sin theta. This form is known as the polar form of the complex number. This is known as the polar form of the complex number. Here r is the modulus in this form. Here r is the modulus and theta is the argument or amplitude. So these are the two forms of the complex number, that is the number that can be written in the form z equal to x plus iy, where x and y are real and I is an imaginary number equal to root over minus 1. This is called a complex number. And modulus of z is defined as positive square root of x square plus y square. If we take x equal to r cos theta and y equal to r sin theta, then z takes the form r into cos theta plus I sin theta, and this is known as the polar form of the complex number, where r is the modulus and theta is the argument or amplitude. Now I am taking one example. If z equal to x plus iy and z minus I by z minus 1 is purely imaginary, show that x minus half whole square plus y minus half whole square is equal to half. You are given z equal to x plus iy. First we simplify it, z minus I by z minus 1. So put z equal to x plus iy. So that gives, take the real part x and imaginary part is I into y minus 1, and the denominator is x minus 1 plus iy. So if I want to put in the form a plus ib or x plus iy in this form, so rationalize this. That is, in the denominator you have x minus 1 plus iy. So you multiply numerator and denominator by the negative factor, that is x minus 1 minus iy. As because the denominator contains x minus 1 plus iy, so multiply numerator and denominator by x minus 1 minus iy. Now we take the real part separately, x into x minus 1, I square equal to minus 1. So this is all plus y into y minus 1 by a plus b into a minus b. This simplify it, that will give x minus 1 whole square plus y square plus I into, this is the imaginary part, x minus 1 into y minus 1 minus xy by x minus 1 whole square plus y square. Now what you were given? This part, that is z minus 1 I by z minus 1 is purely imaginary. So when a complex number is purely imaginary, if I take z equal to x plus iy, when it is purely imaginary, when the real part is 0, that is x is equal to 0, when the real part equals to 0. So this is of the form a plus iv. What is the real part? X into x minus 1 plus y into y minus 1 by x minus 1 whole square plus y square. So by our problem, this part equal to 0, that gives x into x minus 1 plus y into y minus 1 equal to 0. After simplification, you will get x square plus y square minus x minus y equal to 0, and then after simplification, x minus half whole square minus y minus half whole square is equal to half. Next we come to the next problem. If z1 and z2 are two complex numbers such that mod z1 is equal to modulus of z2 and argument of z1 plus argument of z2 equal to pi, then show that z1 is equal to minus z2 bar. What is our z2 bar? Just we mention it. If z be a complex number, z equal to x plus iy, z bar is the conjugate of z. This is defined as x minus iy. This is the conjugate of z and denoted by z bar. That is, the sign of the imaginary part will change. If it is plus, it will be a minus. If it is minus, then it will be plus. So what you are given, z1 and z2 be two complex numbers such that mod z1 is equal to mod z2 and argument z1 plus argument z2 equal to pi, so that z1 equal to minus z2 bar. So let us take the polar form of the two complex numbers, that is z1 equal to r1 into cos theta 1 plus I sin theta 1 and z2 is equal to r2 into cos theta 2 plus I sin theta 2. Now what you are given, mod z1 is equal to mod z2. Just now I told you that if z be a complex number, z is equal to r into cos theta plus I sin theta. What is the modulus? Here the modulus is r. R is known as the, in the polar form, r is known as the modulus of the complex number. So here by the problem, you are given r1 equal to r2. And what is the amplitude? Here for the complex number z1, amplitude is theta 1, and for the complex number z2, amplitude is theta 2. So we are given theta 1 plus theta 2 equal to pi. You can write theta 1 is equal to pi minus theta 2. Now what you have to show, z1 equal to minus z2 bar. So first you start from z1. z1 equal to r1 into cos theta 1 plus I sin theta 1. You are given r1 is equal to r2. So for r1 you put r2 and for theta 1 you put pi minus theta 2. Cos of pi minus theta 2 plus I sin pi minus theta 2, and we know that sin of 180 minus theta, sin of pi minus theta, this is our sin theta, and sin of and cos of pi minus theta, this is our minus cos theta. This is our minus cos theta. So this cos of pi minus theta 2, that is minus cos theta 2, and here sin of pi minus theta 2 is equal to I sin theta 2. So if you take minus outside, minus r2 into cos theta 2 minus I sin theta 2. Now what is our z2? z2 is equal to cos theta 2 plus I sin theta 2. And what will be the conjugate of z2? z2 bar. This will be equal to, just change the sign of the imaginary part. So z2 bar will be equal to cos theta 2 minus I sin theta 2. So for this part, r2 into cos theta 2 minus I sin theta 2, we can write minus of z2 bar. So z1 you have started from z1 equal to minus z2 bar, and this is what we have to prove. Thank you.